Hi everyone, I'm Sanya Mahajan and I'm an incoming junior at Cornell University studying computer science, and this is my second summer. I'm kind of working with Anno on project relating document generation. So today I'll be sharing how we've been improving RAG models for document generation at Anno with a focus on structured, accurate proposals and creating them, especially for use cases like SBIR grants. So let's start with the problem. Requests for proposals like SBIR grants, which are a form of grant proposals that many small companies and companies in general often submit to in order to gain funding for their companies, are often dense and unstructured. Teams have to manually create detailed content across multiple sections, which takes time and is also prone to inconsistency. Our goal is to streamline this using relevant documents, not just like by blindly generating text with AI, but by anchoring outputs in actual documentation that teams already trust. So instead of relying on fully manual writing, we use RAG, or retrieval augmented generation. What's exciting is how modular this is. We retrieve, pair, and then we generate content based on specific instructions. So first we're going to pull relevant internal documents and then pair them with specific instructions extracted from the RFP, or request for proposal. At the last step is generation, where we kind of use large language models to produce section responses. This helps to avoid hallucinations and ensure that the content that we produce is grounded, targeted, and reusable across domains. Improving RAG is really important and essential because it really just influences the generation and the quality of the document that's being proposed. It's not just about correctness, but it's also about usability and trust. So better RAG reduces hallucinations by anchoring responses in real content. It improves specificity by tailoring outputs to each section's exact instruction and information that it's already fed and knows. And along with that, it allows us to scale across domains with minimal extra effort. So, talking a little more about the project that I've been working on that relates a little more to document generation is finding a way to kind of streamline the grant proposal process. And what that means is a lot of small companies have to apply to these grants in order to gain funding. But applying to grants takes a lot of time and a lot of effort, and that effort can be kind of diverted elsewhere where it may be needed. So we're trying to find a way to kind of automate that process so companies have an easier time applying to them. In our end-to-end process right now, here's what it looks like. The input right now is a raw grant URL or a PDF. We extract only the content-specific instructions, and then we retrieve relevant chunks from our internal base using ChromaDB, which I'll go into a little later on. And then from there, we generate section-by-section content, which we've learned kind of helps our model produce the most accurate responses instead of going and producing content for the full proposal, just going section by section. And then we refine that entire document again for tone, clarity, and accuracy. So with this strategy, we prioritize extracting just the relevant prompts. So things like technical objectives, commercialization plans, problem statements, and methods. But we filter out compliance, cost details, and formatting, and any other details that would help to reduce noise and make the writing more focused and aligned with what's being asked. That really just helps with generation accuracy, token waste, and also helps to prevent hallucinations in the model as well. So in looking a little more at the architecture, the retrieval system is built from internal scraped documents and indexed using semantic embeddings. So each section's content is retrieved separately, and that just helps to improve grounding, meaning that we're not just like matching with surface keywords, but also we're going deeper into more relevant content that is relevant to the actual instruction that we give the model. So we use ChromaDB as the retrieval backbone for our pipeline. So after scraping and cleaning relevant internal documentation, including past applications, as well as just like grant writing proposals and the information that we're giving, we embedded these documents and stored them in Chroma. So when we extract a specific writing step, like describe the challenge that your company aims to solve or something like that. We convert that into a vector and query ChromaDB for the top K or most relevant document, most similar documents. So that really just helps to ensure that every generated paragraph is based on the most relevant context internally, even if the language of that prompt just varies slightly. That really just helped our system speed up and easier to scale. So because it's a local store, we avoided repeated calls and we avoided having to re-embed the same documents each time. So for each instruction, after we kind of retrieve that top matching context using ChromaDB and blend it with the prompt, we generate a structured response, and that kind of modular structure that we have really streamlines the process and reduces the risk of generic answers to these proposals that companies might be applying to. So on the next slide, I kind of have an example that's a little more, just a little more about the description of a product and how it might look if with an improved RAG model in general. So we have two product descriptions here on the right. So we have the before and after, one with context and one with no context and one with retrieved context. So one might look like this is a high quality water bottle that keeps your drink cold and perfect for everyday use. Another one with retrieved context is going to say RW insulated stainless steel bottle keeps drinks cold for 24 hours. It's tested during a 10-mile summer hike. With a built-in tea infuser and leak-proof lid, it's trusted by over 200,000 customers worldwide. So as you can see, the example with retrieved context, it's specific, it's tied to use cases, it tells a story, and that's the power that RAG has with grounding it based on real information and retrieved information. So in order to improve accuracy, we've implemented quality enhancements, and we're working on continuing to implement these, such as deduplication of similar prompts, and also just finding similar prompts in general using term frequency, inverse document frequency, and cosine similarity. We also want to get rid of redundancy, so filtering for headers, re-ranking context, and then we're also working on tone and clarity revision. So these are some of the measures that we hope to take, but are also have some measures implemented for. So just to go a little more into TF, IDF, and cosine similarity, term frequency, inverse documents frequency kind of measures how important a word is to a document relevant to a collection of documents. So if a word appears more frequently in one document, but not across others, it gets a higher weight. So among common fillers, this helps us distinguish content-specific terms. And then once we've kind of like vectorized the writing instructions, we can calculate cosine similarity, and that is going to measure the angle between two vector representations. So essentially, we applied this technique to deduplicate writing prompts during pre-processing and also to remove close to duplicate grant instructions. So we found that often grant language would repeat with minor wording changes and redundancy, and that led to repetitive outputs. And we really wanted to make sure that the outputs that we were getting were unique and were very specific to what we wanted to tailor it to. So with that, and with making changes to that, we've been able to achieve more of like a leaner input, but at the same time reduce token usage, which helps speed up the product and improve the generation focus in general. So just a little more into the results. We've seen reduced hallucinations, as I've talked about before, clean and relevant responses for each section, and then also the model supports both manual and automated workflows. So we have that modular design that I was talking about earlier as well. We also have stronger draft content. So essentially our product creates a draft and then filters it out again to make sure that it's accurate, it's concise, and it's relevant. But we see that version 1 is also strong itself, which is always good to see. And then we also see that models can be used interchangeably, and retrieval tools can be used interchangeably. So also making it flexible in that sense has been good to see. And then also, I wanted to highlight when it comes to improving retrieval augmented generation models, and we've our ANOT has done past research on it before, and I wanted to take the time to kind of highlight findings from two papers that were written from the ANOT team and members of the ANOT team, um, and kind of shared their findings as well. So here are two papers that I had the opportunity to kind of look at internally, and then look at like the key lessons. So key lessons from here are retrieval quality and determines answer quality, and then iterative fine tuning and user feedback can help address edge cases and also boost domain specific model performance. So whether it's like healthcare or anything like that. And then human feedback can play a really important role in improving weak spots over time. So um, those were just some of the findings that I also found when it comes to improving RAG models, and some that I'll definitely be looking to kind of implement in my own work with document generation. But when it also comes to future implications, we see that definitely looking to fine tune models for domain specific context is a huge area for work, and as well as that, looking at more advanced retrieval techniques and exploring alternative training methods to see which one runs the fastest, which one outputs the most accurate results, or the most specific are definitely areas of consideration for the future.